Build factor pairs. Hop the multiples. Prime or composite.
In the acorn grove, math isn't about memorizing a list of rules. Words like factors, multiples, primes, and composites can feel disconnected when they're just text on a page. But Hazel the red squirrel has a practical way to manage a horde. Hazel sorts these acorns by nudging them into perfectly equal rows, and the parts that make it up. By treating numbers as physical objects that take up space, we can use these equal rows to answer questions about factors, multiples, and the identity of the number itself. Let's start by looking inside a number. We want to find every possible piece or factor that makes up the number 24. We begin by laying all 24 acorns into a single long line. That's our first rectangle, one row of 24. If we cut that line in half and stack it, we get our second shape, 2 even rows of 12. We keep reshaping the pile. The acorns settle into 3 rows of 8 and then 4 rows of 6. These are all the ways to arrange 24 into equal rows. The side counts of these rectangles are the factor pairs. Because these shapes are perfectly even, we know that 1, 2, 3, 4, 6, 8, 12, and 24 are all factors of the total. Every rectangle we can build reveals a new pair. If a configuration doesn't form equal rows, that number isn't a factor. We can also use this logic to look forward. Instead of breaking 24 down, let's see if 30 is a multiple of 5. Testing for a multiple is like stretching an equal row across the grove floor. We move in steady, repeated jumps. We count by fives: 5, 10, 15, 20, 25, 30. To be a multiple, our jumps have to land exactly on the target number with nothing left over. Since Hazel lands squarely on the stone marked 30, we've proven the result. 30 is a multiple of 5 because it is exactly 5 counted 6 times. Multiples are simply the result of repeating those same equal rows end to end. Whether we are breaking a number apart or scaling it up, the geometry remains the same. This ability to form shapes also tells us what kind of number we're dealing with. Let's classify 7 and 12 as either prime or composite. When we try to sort 7 acorns into equal rows, there is only one way they will fit: a single row of 7. No other rectangle works. This is a prime number. It's mathematically rigid, meaning its only factors are 1 and itself. Now look at 12. It's much more flexible. It easily snaps into 2 rows of 6, or even 3 rows of 4. Because 12 can form rectangles beyond that first single row, it is a composite number. It has more than just 2 factors. You can identify any number just by checking its physical capacity to bend into new shapes. The evidence is all over the grove floor. We found factor pairs in the rectangles of 24, tested multiples on the stepping stones, and used those same shapes to separate the prime from the composite. Each of these answers came from one action: building equal rows. Seeing numbers this way makes upcoming challenges, like fractions and long division, much easier to visualize. Before you head home, try it yourself. If Hazel has 16 acorns, what are the factor pairs? And is 16 prime or composite? When you can see the shape of a number, the math tells its own story. I'll see you at the next bend.
Rows reveal factors. Multiples land exactly. Prime has 2 factors.